So this is an overlook for Horseshoe Park in Rocky Mountain National Park. And there's a number of things to take a look at here. One of which is we're very lucky in that there's a couple moose crossing Horseshoe Park just down there. But for geology, the main things we can see here is over my right shoulder, we see the Alluvial Fan, which we'll go down and take a closer look in a minute. And that's being formed by a hanging valley that we can see over there as well. And then over my left shoulder, we can see a lateral moraine, which is that ridge just up there. And that's the pair to the lateral moraine that where I introduced moraines and till and glacially transported material. So I just wanted to provide a little bit more information before we move down to the Alluvial Fan. So here's this picture showing us the lateral moraine. And like when we discussed lateral moraines over in Many Parks Curve, give a sense of scale, and that lateral moraine is about 600 feet high, which gives us an indication of the approximate height of the ice that was in this valley at about 20,000 years ago. This vantage point is about 200 feet above the floor of Horseshoe Park, which means there was about 400 feet of ice above our heads. Let's take a look at a topographic map to see how that lateral moraine, the glaciation, is all connected to the Alluvial Fan. So here down in the southeast corner of this map is the overlook, and looking to the north is the lateral moraine, and the Alluvial Fan is slightly to the northwest. And the red triangle gives us the approximate extent of the Alluvial Fan. Here I've done a real quick reconstruction of the two prominent glaciers that play a role in the formation of the Alluvial Fan. We have the main Fall River Valley, which was a very large glacier, and then to the north we have a glacier that was flowing down the Roaring River Valley. And the blue lines are the approximate flow paths, which mimic the drainage pattern that we see today. And the seas are prominent cirques that are at the heads of various lobes of that glacier. Now, the glacier that was in the Roaring River Valley was not nearly as big as the one in the Fall River Valley, which means that it couldn't erode its base down to the same level as the Fall River Valley Glacier. And so what that sets up is a very steep slope at the end of the valley that the Roaring River is in when it enters the Fall River Valley. And that is represented today by Horseshoe Falls. Alluvial fans is a generic term of any cone-shaped deposit of stream sediments that form when a narrow valley opens up into a larger valley, such as we see here, that's set up by this hanging valley. And if you recall, hanging valleys are formed when a smaller glaciated valley with a valley floor that's above a much larger glaciated valley join each other. A majority of the Alluvial Fan was deposited in a flood in the early 1980s. And that flood occurred when a dam on Lawn Lake failed, and the water rushed down the Roaring River, a distance of approximately 4 miles. And then when those floodwaters exited the Roaring River Valley and traveled down Horseshoe Falls, they spread out and slowed down, depositing a large amount of sediment. So in the next video, we'll go down to the Alluvial Fan and take a look at some of the details of the sediment that was deposited in that flood and subsequently.